In section 6.5, we are solving equations by factoring. Our objectives are to learn and use the zero factor property, as well as solve applied problems that require the zero factor property. The zero factor property. If two numbers have a product of 0, then at least one of the numbers must be 0. So if a times b equals 0, then either a is equal to 0 or b is equal to 0. It is important to note that the zero factor property only works for a product equal to 0. Here's an example of an equation that we're going to solve using the zero factor property. We have the entire quantity x minus 3 times the entire quantity x minus 2 equals 0. So either one of these factors must equal 0 for the equation to be true. So to use the zero factor property, we set each factor equal to 0. If the first factor equals 0, then x minus 3 equals 0. We can solve this equation for x by adding 3 to both sides. The solution is x equals 3. 3 is one solution to this equation. The other possibility is that this second factor is equal to 0. So we can set x minus 2 equal to 0 and solve this equation for x by adding 2 to both sides. And we get x equals 2 is another solution to this equation. And you can check your answer for both of these to make sure that you get a true statement. To check the solutions, for example, if x equals 2, you plug 2 into x in the original equation. When you do that, the first factor is 2 minus 3 and the second factor is 2 minus 2. Simplifying what's in the parentheses, we get negative 1 times 0, which equals 0, so we know that's a true statement, and our original solution checks. We also want to check if x equals 3 is a solution by plugging the 3 in for x in the original equation, and by substituting in for 3, we get 3 minus 3 in the first factor and 3 minus 2 in the second factor. That simplifies to 0 times 1, and that does equal to 0. So we know both of those are solutions to the original equation. Now, a quadratic equation can be written in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. We call this a quadratic equation in standard form. To solve a quadratic equation by factoring, we follow the following 5 steps. Step number 1, write in standard form. Rewrite the equation if necessary so that one side is 0. Step number 2 is to factor the polynomial. In our previous sections, we've practiced the factoring part. We're adding an additional step here by solving an equation using the zero factor property, which is step number 3. You're going to set each variable factor equal to 0. Step number 4 is to find the solution or solutions. Solve each equation formed in step 3. In step number 5, we check each solution in the original equation. Let's solve this quadratic equation. We need to first make sure the equation is written in standard form. In other words, rewrite the equation if necessary so that one side is 0. To do that, we can subtract 3 from both sides. Our equation becomes 2x squared plus 5x minus 3 equals 0. Step number 2 is factor the polynomial. Now on the left side we have a trinomial. It's not a simple trinomial, so we can use the AC method. In the AC method, we are multiplying a and c together. In this case, a is equal to 2 and c is equal to negative 3. When we multiply 2 and negative 3 together, we get negative 6. We list the factors of negative 6, and we want to find the factor that adds up to the middle term. The factors of 6 are negative 1 and positive 6, negative 2 and positive 3, negative 3 and positive 2, or negative 6 and positive 1. We want to find that one pair of factors that adds up to the middle term of positive 5x, and that pair is negative 1 times 6. because -1 plus 6 is equal to +5, which is the middle coefficient. Now we split up the middle term and factor by grouping. The first term remains 2x squared. The middle term is split in two, one of the terms being -1x and the other term being +6x, by using the factors found in the list. And then the last term is -3. Now we can factor by grouping. Look at the first group and determine the greatest common factor of that group. The greatest common factor is x. If you factor out the x, you will have left 2x minus 1. Now we look at the second group, the +6x minus 3. The greatest common factor of those two terms is a +3. Whatever sign is in the middle here, that's the sign that we're going to factor out. When you factor out 3 from the last two terms, dividing out the 3, we get 2x minus 1. Now we notice that the two larger groups have that common factor of 2x minus 1. So that is one of the factors of the polynomial. The other factor is what's in front of those common factors, and that is x plus 3. So x plus 3 is our other factor. Now using the zero factor property, we're setting each of these factors equal to 0. If we set 2x minus 1 equals 0, we can solve this equation for x by adding 1 to both sides to get 2x equals 1, and then divide both sides by 2 to get x equals 1/2. That's one of the solutions to our original equation. We also set the other factor equal to 0. So x plus 3 equals 0 can be solved by subtracting 3 from both sides, and we get x equals -3. That's another solution to the original equation. And our last step is to check. We want to make sure that both of these are true statements in the original equation. Our original equation is 2x squared plus 5x equals 3. Let's check x equals 1/2. 2 times 1/2 to the second power plus 5 times 1/2. We want to make sure that that equals +3. By simplifying, we get 1/2 squared is 1/4 times 2 is 1/2. 1/2 plus 5 times 1/2, 5/2, does equal 6/2, which is simplified to 3. So we know that is a solution. X equals 1/2 is a solution to the original equation. Let's check x equals -3. By plugging -3 into the x in the original equation, we get 2 times the quantity -3 squared plus 5 times -3. We want to make sure that equals 3. Using the order of operations, doing the exponents first, -3 squared is 9, and 9 times 2 is 18, and 5 times -3 is -15. 18 minus 15 does equal 3, so we know that is also a solution to the original equation. Our solution can be written using set notation or writing out each individual equation. By using set notation, we can say the solutions are 1/2 and -3. Let's solve this equation. 9x squared equals 24x minus 16. Our first step in solving any quadratic equation is to write the equation in standard form. Rewrite the equation if necessary so that one side is equal to 0. So to do that, we can subtract 24x from both sides of the equation, as well as add 16 to both sides of the equation. By moving those over to the left side of the equation, the right side of the equation will equal 0. So we get 9x squared minus 24x plus 16 on the left side of the equation, and that's equal to 0. Now we can see that we have a trinomial. This is not a simple trinomial, so you could use the AC method. For the AC method, you multiply A and C together. A times C is equal to 9 times 16, which is equal to 144. Now we can find the pairs of factors of 144 that will add up to give you the middle term of negative 24x. Now 144 is 12 times 12. That will give you a positive 24, so another pair of factors is negative 12 times negative 12. That will add together to give you negative 24x. So that middle term is going to be split. The first term stays as 9x squared. The middle term, we can write it as minus 12x minus 12x. The last term is plus 16. Now we can factor by grouping. Look at the first group and determine the common factor. The greatest common factor of 9x squared minus 12x is 3x. If you factor a 3x out of the first two terms, you're dividing each of those by 3x to get 3x minus 4. Now let's look at the last two terms, the minus 12x plus 16. The greatest common factor for those is minus 4. So we're going to be factoring out a minus 4 because that middle sign is a negative sign or a minus sign. We're factoring out the minus 4. And when you factor that out, dividing the negative 12x by negative 4, we get positive 3x. And the positive 16 divided by negative 4, we get the minus 4. And that is equal to 0. So our two factors, notice that in the larger groups, they have a common factor of 3x minus 4. That's one of the factors of the polynomial, 3x minus 4. And the other factor, when you take out that 3x minus 4, the resulting factor is also 3x minus 4. So this ends up being one of those perfect square trinomials that can be factored as 3x minus 4, the entire quantity squared, equals 0. Now we can use the zero factor property, setting each of those factors equal to 0. Since the factors are the same, if we set the first factor 3x minus 4 equal to 0, we'll get the same answer as if we set the second factor equal to 0. So we can solve this equation by adding 4 to both sides, and then we get 3x equals 4. Solving that, we get, by dividing both sides by 3, we get x equals 4/3. So that's a solution to the original quadratic equation. And we can check this solution by plugging it back into the original equation, which was 9x squared equals 24x minus 16. When we substitute in 4/3 for x, we get 9 times the quantity 4/3 squared equals 24 times x, which is 24 times 4/3, minus 16. All right, when we square 4/3, we're squaring the numerator and the denominator. So that's going to give us 9 times 16 divided by 9. And the 9's will divide out so that the left side of the equation is equal to 16. On the right side, we have 24 times 4/3. A way to simplify this is by dividing the 24 by dividing the 24 by 3 to get 8, and the result is 8 times 4, which is 32. And 32 minus 16 is also equal to 16. So we know that that is a solution to the original equation. So our solution is x equals 4/3. Let's solve 7x squared plus 42x equals 0. Again, the first step in solving a quadratic equation is to write the equation in standard form. Now, we rewrite it if necessary so that one side is 0. We can see that one side is already equal to 0. Step number 2 is to factor the polynomial. Since this is not a trinomial, we don't need to look at factors that add up to the middle term. But what we can do is find a greatest common factor, what goes into both 7x squared and 42x, and that greatest common factor is 7x. So you can factor out that common factor of 7x, and when you're factoring out the 7x from both of those terms, you're dividing out, and the other factor is going to be x plus 6. So we do have two factors here. The first factor is 7x, a monomial, and our second factor is the binomial x plus 6. We're going to set each factor equal to 0 and solve for x. When we set 7x equal to 0 and divide both sides by 7, we get x equals 0 is a solution to the equation. When we set the other factor x plus 6 equal to 0 and subtract 6 from both sides, we get x equals negative 6 is another solution. We want to check our solutions by plugging those back into the original equation, which was 7x squared plus 42x equals 0. When we check x equals 0, substituting in 0 for x, we get 7 times 0 squared plus 42 times 0, and simplifying this, 7 times 0 squared is 0, and 42 times 0 is 0, so 0 plus 0 does equal 0. So we know x equals 0 is a solution to the original equation. Let's check x equals negative 6 by plugging negative 6 in for the x in the original equation. When we do that, we get 7 times negative 6 squared, which is 7 times 36, plus 42 times negative 6, which is negative 252. We want to know if the left side of the equation is equal to 0. And then 7 times 36 is 252, plus a negative 252, that does equal 0, so that is also a solution to the original equation. We can write our answer as the two separate x values. We can also use the set notation to denote that 0 and negative 6 are both solutions to that equation. Let's solve this equation. X to the third plus 2x squared minus 9x minus 18 is equal to 0. This is not a trinomial, and there is no greatest common factor, but I do notice right away that there are 4 terms. If possible, we want to try to factor by grouping. Look at the first group and determine the greatest common factor. It looks like the greatest common factor is x squared. So if you factor out an x squared from the first 2 terms, what you'll have left is x plus 2. Now let's look at the second group here, the minus 9x and the minus 18. The greatest common factor of those two is minus 9. And when you factor out the negative 9 or the minus 9, dividing negative 9x by negative 9, you get positive x, and dividing negative 18 by negative 9, you get positive 2. Now let's look at both larger groups here. You see the common factor is x plus 2, so one of those factors is x plus 2, and then what we have left in front of the x plus 2 factors, we have x squared minus 9. Now notice that x squared minus 9 can be factored further. This is one of those special trinomials. Well, actually it's a binomial, but it can be written as a difference of 2 squares. Recall the formula for factoring x squared minus y squared. The factors are x plus y and x minus y. So our factors now become x plus 2 is our first factor, and x squared minus 9 can be factored as x plus 3 and x minus 3. We're going to set each one of those factors equal to 0, setting the first factor equal to 0 and subtracting 2 from both sides, we get x equals negative 2. Setting the second factor equal to 0 and subtracting 3 from both sides, we get x equals negative 3. And setting the last factor equal to 0 and adding 3 to both sides, we get x equals 3. we have our three solutions. We do want to make sure each one of those checks in the original equation. So take the time to do that on your own, and one way that you can write your answer is those three separate answers. You can also use the set notation and denote that -2, -3, and +3 are all solutions to this polynomial equation. Using a quadratic function in an application, the manufacturer of a weather radio has determined that the revenue R from the sale of radios can be approximated by using R equals -100p squared plus 1300p, where p is the selling price of each radio. What is the selling price of the radios if the revenue is equal to 4,000? So let's take our equation, and the fact that we want to know what the selling price is, we want to find P when the revenue is 400. Well, the revenue is the R value, which is 4,000. We're going to take this equation for R. R is equal to -100p squared plus 1300p, and we're going to replace the R with the given value of 4,000. So 4,000 is equal to -100p squared plus 1300p. This is a quadratic equation. The way we can solve a quadratic equation by factoring is to first write it in standard form. Rewrite the equation if necessary so that one side is 0. So what we can do is add 100p squared to both sides of the equation. And we can also subtract 1300p from both sides of the equation. Now we can write the equation in standard form so that it looks like 100p squared, oh, that should have been a p there, minus 1300p plus that original 4,000 here on the left side is equal to 0 on the right side. Now this is a polynomial equation. We can solve it by factoring. I do notice that all of these coefficients are multiples of 100. So before trying to factor this using the AC method, I'm going to factor out a greatest common factor of 100. When you factor out 100 from all of those terms, you're dividing each one of those by 100. So 100 divided by 100 is 1. 1300 divided by 100 is minus 13p. And 4,000 divided by 100 is 40. So we have this polynomial. The trinomial is a simple trinomial that can be factored by looking at the last term of positive 40 and listing the pairs of factors of 40, which are 1 times 40, 2 times 20, 4 times 10, 5 times 8, as well as the possible negative values, -5 times -8. And actually, I can tell right away that this pair of factors here, -5 and -8, will add up to the middle term. So this simple trinomial can be factored, leaving that greatest common factor of 100 out in front, into p minus 5 and p minus 8 equals 0. Now we set each one of those factors equal to 0 using the zero factor property. If we set p minus 5 is equal to 0, we get p equals 5. Set p minus 8 equals 0, you get p equals 8. So the selling price could either equal $5 or $8, so that the revenue would be 4,000. Now this concludes the videos for Chapter 6. Work through the material, work through the homework, take the practice tests, and be ready for the actual test.